Hi, good afternoon. Welcome back. Welcome to a new session. Let me welcome André König, who is a reference in the quantum community. Welcome, André, to Quantum-Latino. Let me introduce you. André is a published author, speaker, and expert on deep tech with 25 years of Fortune 500 consulting and startup experience. He's the CEO of Interference Advisors, the premier data provider within quantum tech, chairman of One Quantum, the leading quantum tech community organization, and he's managing partner of Entanglement Capital, a quantum tech investment fund and startup accelerator. He studied quantum computing at MIT with certificates and holds an MBA in economics from the University of Chicago Booth School of Business, as well as a master in business from ICN School of Management. He speaks English, German, and French, and has competed in national small boat sailing championships. He will share his vision about quantum technology, where we are in winter, we are in a bubble, or what is happening. So, André, thank you very much for your presence. You are more than welcome. The floor is yours.
Muchas gracias, Rafael. It's a pleasure to be with everybody. I would have hoped to speak Spanish by now, since I live in Miami for 2 years, and this is clearly not an English-speaking city in the US, but hopefully next year when you do the second edition of your conference, we can do this in Spanish. I'll promise to practice.
Okay, we can help you with that.
Good. We'll do mutual visits. While I share my screen here.
Go ahead.
Again, excited to be with everybody. I really look forward to this Quantum-Latino kickoff and future interactions. The way I work in quantum is through the lens of data, and that is just through my personal background, having studied economics, but also for the last 10 years being an entrepreneur, mostly in artificial intelligence before I got into quantum computing 3 years ago. And Edward Deming, who's a very famous engineer and process person, had this beautiful quote that without a data, you're just another person with an opinion. And the reason that I think that is so important in quantum tech is because it's a spooky field. Einstein said that, right? It's also a very complicated and difficult to understand field. And we all read about it in the news. We all know somebody in quantum. And it is really difficult to kind of understand what is truly happening. So my goal today will be to offer you a little bit of my vision, but I think quantum potentially could do, and we all should aspire to do. Compare that to where we're at today, and maybe give some suggestions, philosophical suggestions, on how we can close that gap. The reason that I'm really focusing on this data kind of aspect of quantum is just because we are all so victim of cognitive biases. Cognitive biases is this idea that we think we know something, or we think we saw a fact somewhere, and we extrapolate from that and turn it into a bigger truth. So sharing with you as many facts as I possibly can, so that we all, from data through information, can create our own knowledge, come up with our own insights, as all of you through Latin America build your quantum businesses and hopefully your quantum wisdom. As Rafael pointed out, I run 3 companies, Interference Advisors, which is a Gartner pitch book of quantum. We've collected to date 30,000 data points on the quantum tech ecosystem. Who are the startups, the vendors, the products, the technology, use cases, investors, anything that you can think about. One Quantum, which is a global community organization organized in chapters. We have a startup chapter that Quantum South joined. Thank you, Martin and Rafael. A really large Women in Quantum chapter where we support women working in quantum or wanting to get into quantum. And many regional chapters, Uruguay, putting a little bit of pressure on you guys here to start that, but anybody throughout Latin America that would want to start as a volunteer president a chapter of ours and help with community building, mentoring, career services, and ultimately working on quantum projects, reach out to me. I also run a very small, tiny little quantum tech investment fund. Anybody that would like to talk about investments and money in quantum, reach out to me. So I'm sure you all have seen use cases, fantastic speakers and companies on the agenda. I'm not sure if any of them has really given you, the vision, what is possible. And I think quantum tech is one of these unique opportunities to dream. It is such a new and radically different technology that things that we really only know from science fiction movies are theoretically possible. We're far away from that, just to be very clear. I will repeat that many times throughout this presentation, but some of these things are possible. And I think we all should dream about them, because if we don't dream about them, nobody is going to make it happen, right? And this is an opportunity for everyone. You don't have to go to MIT, to Cambridge, to Stanford. You don't need 100 million in funding necessarily to dream and come up with on these use cases and applications. So what is possible? Star Trek, beam me up, Scotty. Theoretically proven, and we have done it at the minuscule scale in labs already. So theoretically something to work on. Tony Stark, what made him different? New materials, new sources of energy, new vision technology. You've all seen the movies, hopefully, if you haven't checked them out. All things that become possible through quantum computing and other quantum technologies, sensing, communications, and so forth. Really think about what that means for our world, rather than just improving existing products and existing technologies. Time travel. Scotty, who in his beautiful DeLorean car traveled through time, also something that we've done in the lab at a very experimental level, and decades away from making this a reality. But think about it. Just have this vision and this ambition to think big. More practical. Beautiful lake here. I'm not sure where it is. You see the snow-covered mountaintops in the back. A clean environment, carbon extraction, clean water. We have a Nepal chapter at One Quantum where we're talking about how can we reduce trash at Mount Everest, which is the largest industry for Nepal's economy, and trash at Mount Everest is the largest issue in terms of that tourism industry. Who doesn't want to be at the beach, right? I'm overlooking the beach of Miami right here. It's 2 minutes away. I haven't been in months, too busy working, and not complaining about it by any means. But universal wealth is theoretically possible through quantum technologies, as is universal healthcare, personalized healthcare. How long can the human live? 120, 150, 200 years? Do we want that? I don't know, but theoretically, all of this is possible through quantum computing. The city of the future. Not sure if this is a place that I want to live in. That doesn't look very exciting to me. Maybe I need to find a different picture. But again, all of these technologies that would make that possible, self-driving cars, self-driving airplanes, unlimited energy, new materials, all of that is possible through quantum technologies. So, my challenge here, for those of you that are new in quantum or starting out, think big and don't just follow what the rest of the ecosystem does. What is the ecosystem? Let's take a little look at where we're at. You probably have seen many aspects of this graphic already. What this basically says is that, at the very bottom in blue, you have a hardware layer. And in quantum computing, we talk about quantum computing hardware. So those vendors and startups that actually build the physical qubits, the measurement and control mechanics that go around it, and then do the readout of those qubit and circuits executed on them to obtain a result. Above that, we need an instructional layer and a software layer that allows us to do something useful, some of these use cases with it. And at the very top, we need algorithms, which for me is one of the most pressing, urgent, and interesting aspects of quantum. We need a mathematical way to describe all of these use cases, opportunities, and challenges in a quantum language. So when you look at the ecosystem, and there are different ways to slice it and dice it, this is just one example. That is kind of where you should be thinking about hardware, software, algorithms, and how does that pertain to all the different use cases that you might be looking at. Here's a little overview. Again, this has no claim of being exhaustive. It's just to help you think through it a little bit. Technically, a quantum computer, it's this question of NP versus NP hard problems. What theoretically a quantum computer can do and offer a speed up over a classical situation. On the left side, you see some of these areas of opportunities, from prime factoring, Monte Carlo, which is used in finance a lot, optimization problems, machine learning problems, VQEs, and industries where some of these problems apply. As an entrepreneur, which is a lot of my focus, working with entrepreneurs, you have to start to think about, where can I get a theoretical quantum speed up over classical infrastructure? And where do I find a market for it? In what industries? In what verticals? What applications? And then you kind of have to look at, how big is that potential result that we're even looking at? And how big is that market? And when you go through an exercise of this, and I'd love to discuss with you where you agree or disagree in this matrix, but let's come up with a matrix and think about it intelligently. There really aren't that many opportunities today, at the end of the day, to deliver a business enterprise result that is so much better than a classical result. And I'm not talking about today, I'm talking about a couple of years, 3 years, 5 years out, because we still haven't found these big opportunities yet. And we'll talk about that a little bit more in a second. Let's continue to dive into this ecosystem a little bit more, specifically startups in quantum information science. And this is just to show you the trend a little bit over the years 2013, 19, 20. And what you will see here is that the left of these charts, quantum computing dominates versus quantum communications, quantum sensing, and encryption. Quantum computing, very interestingly, is roughly half and half, divided into quantum computing hardware and quantum computing software, which to me is fascinating, because our hardware, while having made tremendous progress, is still fairly immature, right? We still don't even know what to build it out of. Superconducting chips, trapped ions, photonics, so many different approaches. Yet we already have a huge ecosystem of entrepreneurs that are building software, everything that we saw on that stack, from compilers to languages and so forth. What you can also see is that the growth in these quantum computing startups compared to sensing or communications has been much higher over the years, and at a more sustained level. Today, personally, I count about 500 startups worldwide that are truly verifiable publicly, working in quantum information science. I'm sure there are many more. There are teams all around the world at universities. I'm sure many of you are in those shoes, that have IP, that have a license, possibly in the process of forming a legal entity and getting into this game, right? But to give you a little sense of how it has grown over time and where we're at. If you look at it globally, and this map is a little older, you can get a new map on one of my websites, qisdata.com, to see some of the geographical distribution of these startups. And no surprise here, they are still tied, at least that was the case last year, to where a lot of these large universities are, right? So North America, the US, by far the largest host of quantum tech startups. Canada doing surprisingly well, and that in no small part is due through a $300 million gift by Michael Lazarios, who is the founder of BlackBerry, and in his home of Waterloo of Canada, had the ambition many years ago of building a quantum center, and made a huge personal investment to drive that forward. Canada, a fantastic and very strong player. At the other end of that map, you see Australia, which has a very strong ecosystem with a handful of universities and a dozen different startups. Obviously, China and Russia, very big players. It is difficult to find reliable data on these. China has the reputation of having spent the most amount in terms of government grants on quantum, somewhere between 11 and 12 billion US dollars, and really the leader in quantum technologies. We do think that they are focused more on quantum communications and sensing versus quantum computing, but that is hard to verify, and I'm sure they have some tremendous quantum computing hardware solutions as well. Europe, my home, Germany, since this map was created, has invested over 6 billion total into quantum computing, created the Munich Quantum Valley, many other initiatives, and is working with Brussels and different initiatives in the Netherlands, in France, and formerly in the UK. That has changed now with the Brexit, to form a European quantum program as well. And that program now in size, be it the number of startups, the number of research universities, the investment dollars, and the government grants, is the leading program in the world. What we do not have in Europe, of course, and that is the same in any technological innovation over the last few decades, is these big industrial champions, IBM, Google, Microsoft, Amazon. Intel is getting into it, that are supporting that ecosystem in the US. That is something that we only see in Japan as another ecosystem, where companies like Fujitsu, Mitsubishi, and many others are supporting the Japanese quantum tech ecosystem. Latin America, we do count a few handful of efforts, and we will look at that later on. The market size in general, and here I have two slides. This is a slide that we did a year and a half ago. It's very small, and these numbers are fairly well aligned with what other analysts estimate. You see a very conservative but optimistic growth rates. Just looking at revenue potential by all of these companies that we just looked at in the previous slides, it is, a big overall market, but relatively small compared to other technologies. Just a couple of weeks ago, we came up with an update, and you see these numbers after about 18 months have gone up. So we revised our projections upwards from 172 million in 2020 to now 300 million in 2021, and overall a slightly larger market, and that is really due to the progress that we have seen, not just on the hardware, but also on how do startups and large vendors work with Airbus, Volkswagen, all these big users, BBVA, a Spanish bank that is very prominent in quantum. I think the whole ecosystem has made tremendous progress in terms of bringing that value to market, and thus the market overall is improving very much. This is a slide that I'm very fond of. We have looked at 782 founders or CEOs or senior managers at quantum tech vendors and startups and other organizations, 560 total of them. And you see that we do have a diversity problem. 716 of these are men, only 66 are women, which is why we started Women in Quantum with One Quantum. Most of them are like me, white. We do lack African-American representation, Latin representation. So this conference is extremely important. Without diversity, we don't have innovation. Innovation can't be done in isolation in the ivory tower. So this, to me, an extremely important slide. We ranked the top 100 universities, and we ranked them, again, through my lens, which is startups, entrepreneurship, by the number of founders that they produced. And you see a lot of the big names here that one would expect: Oxford, Harvard, Toronto. Number 10, TU Delft, which is a Dutch, very renowned Dutch university in the Netherlands. And the Netherlands has a fantastic, extremely well funded program. But other than that, you see US, Canadian, and a couple British universities. And that picture really doesn't change through the next top 20, top 30, top 40. You have a couple Swiss and German universities popping up. but largely it is what you see here. Quantum tech investments, again, divided by quantum computing hardware, software, QKD, communications, and sensing. Obviously, quantum computing takes the cake here by far. This, I should mention, is private capital investment. So we're not looking at government grants in this chart, but only at angel venture capital, potentially some private equity investors. And you see that the overall numbers have gone down between 2018 to 2020. And obviously the dominance of quantum computing, and within quantum computing, quantum hardware, but that is just a function of hardware obviously being a lot more expensive and capital intensive than quantum software. The overall private capital market in 2020 was $1 billion US. Very interestingly is there were two very significant deals in that statistically skewed that analysis, and they made up half of that sum. So if you look at all the other deals that remain, it was just $500 million in private capital invested in 2020 into quantum tech globally, quantum tech companies globally, and this is just publicly verifiable data. There's a dark number behind that, but I don't expect that to be that much bigger. Just last week, we typically release these numbers every 6 months. So this is an intermediary update that we put together between January and May 2020. There was a total of $445 million invested between January 1st and May 31st, 2021. This year, there was a total of $1.273 billion invested, but on a much smaller number of deals. And again, both of these numbers contain 2 in the case of 2020 and 3 in the case of 2021, very large deals that statistically skew this data. In 2021, that was these SPAC financing deals with IonQ and one other company. If you take those statistical tail ends out, the market hasn't moved. 230 million in 2020 for the same period, 223 million for 2021 over the same period. So no growth there in terms of private capital, but the average deal size has gone up significantly, which is a sign of the ecosystem maturing. Couple targets before we run out of time here. Obviously, this comes out of North America and Europe at this point and goes into North America and Europe with a little bit of China sprinkled in there. Israel really has made big strides over the last 12 months and has joined this map. So color that in there with a very significant number. Breakdowns here, email me if you're interested in those details. We looked at the details, the overall general application of it. So to answer that question, quantum winter or not, we talked about what is possible. We gave you a little bit of an idea what the ecosystem looks like. I think it is important, in my opinion, also to say what it is not. And what it is not, for me, is a consumer technology, at least not in the near or medium term future. I don't see any consumer market, and some disagree with that, but that would be a big potential revenue stream, of course, and I don't see that happen. I don't even see it as a really big enterprise technology. I see it for special purposes, part of innovation teams, these Tony Stark, Elon Musk kind of efforts. I don't expect every Fortune 500 company in the world to spend huge budgets on quantum computer, not in the next 5 to 10 years. It is not an incremental technology, at least in my opinion. It is a real paradigm shift. And that is how, in my opinion, we all should think about it and consider it the breakthrough that it is. With that, we will see if there are any questions. I'll skip over the rest of the slides. We all coming out of a global crisis. Many countries are still dealing with it. Crises, as Winston Churchill said, is the perfect opportunity to innovate, to revolute and do something new. If you'd like a copy of these slides, talk about anything with it, you have my email in the bottom right. You can go to my website, and I'd love to chat about it.
Great, André. Thank you very much. So going back to the title, it is not a bubble, and it is not a winter now.
I don't see a winter. You know, I see there's this very famous technology maturity curve that Gardner one day came up with, right? There's no winter on that curve. There's just this slope of enlightenment and then kind of a consolidation of the market, which is very healthy. Every ecosystem has that. We see it in nature and biology. I think that's what we're heading into. There are some huge war chests. Everybody saw the Honeywell CQC deal, which is going to add hundreds of millions of capital to the market. I think this is healthy. I don't think there's a quantum winter. I do think there might be a quantum winter on algorithms, and we need to do a lot of work on algorithms, but that's an intellectual problem, not a funding or commercial problem.
Fine. Well, we have a couple of minutes for some questions that came from the audience. The first question from Martin says, how the Latin America quantum tech startups by country 2021 map would look like with all new companies uncovered in Quantum-Latino 2021?
Great question, Martin. I was hoping to get it done by today, but couldn't. Why don't we have a little video chat in a couple weeks? I'll come up with my version of the map by then, and we can share it with your entire audience. I would love to kind of paint that map and start getting it out there. I think it's a huge opportunity. We have a big community in Africa. And since we started in Africa with One Quantum a year ago, we've created 3 private companies through our network and put countries on the map that never thought they'd be able to compete in quantum computing.
Fine.
It's still a long way, but let's do the same.
We are receiving thumbs ups. I guess it's from Martin. So another question from Paola, a student, that says, can anybody access to women in quantum, or do we need some level of studies?
All chapters at One Quantum are open to anyone as long as you're interested in quantum, no matter your background, your education, your seniority, your gender, your orientation, your religion. That is the whole purpose. So yes, Paola, please join. Go to onequantum.org, send us an email, or hit up Denise Ruffner from IonQ. She is the president of the Women in Quantum chapter. We have a conference July 19th and 20th. We'd love to have you join.
Okay, and let me add that tomorrow on Friday afternoon, we have a panel of women in quantum, in which Denise is also involved.
Absolutely.
Okay, Paola. And the last question from Eduardo Ignacio, how to convince investors to spend money in quantum technologies in a country in financial crisis like Brazil?
Great question, Eduardo. Send me an email. I would love to talk to you about that. I think what I see is that smaller deals, seed deals, A-round deals are getting a little harder to do. They take more time and more focus and more preparation, but that's the same if you're in Germany, where I'm from, or in the US. So I think you can compete here as long as you have the team, the IP, and we work on your pitch deck, and happy to help. Send me an email. It's all about how you present your opportunity. What exit scenario do you offer your investors? Are you going to build revenue? Do you have a market for that? Very difficult to do in quantum. Do you have a potential acquisition path, a public path? Those are the things that investors care about. And I don't think it matters if you're then in Brazil, any other country that might be struggling. So please reach out. Happy to help.
Excellent. So we have your email. People is clapping. So André, thank you very much for joining us at Quantum-Latino. Excellent presentations. Thank you.
Great to be here. Thank you so much.
Everybody, we will close the session and we will be, please go to the next one. Bye-bye.
Have a great day.